Here we have a triangle ABC. It has two angles we know at 40 degrees and 20 degrees. We have a segment KD that splits the sides AC and BC in a way that a CD is the same length as AB and CK the same length as AD. Now, previously we were solving a problem like this. The difference was that instead of angle of 40 degrees, here we had angle of 60 degrees. And solution was somewhat different. If you're interested to see how it was done previously, there is a link. So this problem we're going to solve now using trigonometry, mostly. And there's going to be another video where we're actually going to use purely geometrical arguments. Before we're going to go into trigonometry, let's do a little bit of geometry. First of all, notice we have a triangle where one angle is twice as large as the other angle. So let's consider a more general case. We have a triangle ABC, angle C is alpha, angle A is 2 alpha, twice as much. So what we're going to do, from point B, we're going to draw a segment, which we're going to call BD, in a way that BD is the same length as AB. Now we got an isosceles triangle ABD, and an isosceles triangle angles at the base should be the same, so angle D here should be 2 alpha. And now remember this 2 alpha is an external angle to triangle BDC, and because of that, that angle 2 alpha should be the sum of angle B and angle C of the triangle BDC, and since C is alpha, B also has to be alpha. If you're not familiar with this fact, it's very easy to prove. I'll leave it for you. Now, since in the triangle BDC, we have two congruent angles. This is an isosceles triangle, and therefore CD should be the same length as BD. So what we got here is we started with a triangle which has two angles, one twice as much as the other one, and we ended up having three congruent segments in this triangle, dull green. So now, if we apply this logic to the triangle above, we find that BD here should be the same length as AB and CD. And this angle D here in triangle ABD should be 40 degrees. And therefore, this angle B right here in triangle ABD should be 180 minus this 40 and minus this 40. And therefore it's 100 degrees. So we're done with geometry. Now we're going into trigonometry. Before we do this, to make things easier for us, let's denote AB as F and AD as G. So essentially any green line will have length F and any red line will have length G. So now what we need to know is two facts. One called law of sines, the other called law of cosines. Let me remind you law of sines. It says that in arbitrary triangle, the ratio of a side to the sine of the opposite angle should be the same for all sides. That's written here. And also it equals to 2 times the radius of the circumscribed circle. Now this fact we don't need right now, but it's just basically a good thing to know. Now let's talk about law of cosines. Law of cosines says that if I know two sides in a triangle, like A and B, and I know the angle between them, I can use this formula to calculate the third length. And law of cosines is often viewed as generalization of Pythagorean theorem. All right, so what we're going to do, we're going to take triangle ABD and apply a law of cosine to this triangle. That's what we're going to get. The next thing we're going to do, we're going to take triangle KDC and apply law of sines to this triangle. The side CD divided by sine of the opposite angle, which is x. That's what we have here. And that equals to side CK divided by the opposite angle, which is 180 minus x and minus 20. That's what we have here. Now, since we know the green sides are F, the red sides are G, let's apply that. This is what we're going to get in case of law of cosines. This is what we're going to get in case of law of sines. Now, I also use the fact here that sine of 180 minus angle Z equals to sine of Z. And that's what I use to replace this expression, this sine, with this sine, okay? Now, if you're interested into details how this formula is obtained, there's a link. So, and in fact, any trigonometric formula I'm going to use now, I'm going to post a link to a detailed description of that fact. Now we're going to take this law of cosines and modify it a little bit. So first of all, notice there is a factor 2f squared we can pull out from both of these terms. And the second fact we need to know is that 1 minus cosine of 100 degrees is 2 times sine squared of 50 degrees. And that follows from the formula for cosine of double angle. Cosine of 2z is 1 minus 2 sine squared of z. In our case, z is 50, 2z is 100 degrees. So now, once we have this formula, we can find g by taking square root of it. This is what we're going to get. And now we're going to replace g in law of sines using this formula. That's what we're going to get. Notice there's f on the left, f on the right. We can cancel it out. Also, let's multiply both parts of this equation by both denominators, both of those signs. This is what we're going to get. Now let's divide both parts of this equation by 2. You may ask why I'm doing this. I'm doing this because I know that 1/2 equal to sine of 30 degrees. Now we can apply this formula for the product of sines that tells us that product of sines times 2 is the difference in cosines. Now we don't have a factor of 2 here, so well, we can just multiply by that factor and then apply this formula. We apply this formula on the left and on the right separately. If we do, this is what we're going to get on the left, this is what we're going to get on the right. Now notice on both sides we have minus cosine of x plus 50 degrees. We can cancel it out. This is what we're going to get. And now let's move this cosine from the right hand side to the left hand side. That's what we're going to get. We got a difference of cosines. And now we're going to apply again this formula in the reverse. So this is what we're going to use. In this case, u will be x minus 10. V is going to be x minus 50. If we apply this, that's what we're going to get. Notice the sine of 40 degrees is positive number. So in order for this expression on the left to be 0, we need sine of x minus 30 to be 0. If we were to solve this as a trigonometric equation, we would get infinite number of x's. But this is a geometric problem, and x is an angle in a triangle. And therefore, this angle is restricted between 0 and 180 degrees. And that means that x minus 30 lays between minus 30 degrees and 150 degrees. And now we are looking for an angle between minus 30 and 150 degrees that has sine equals to 0. In this particular range, there's only one angle like that, and that is 0 degrees. So it means that x minus 30 should be 0 degrees, which means that x equals to 30 degrees, And that's our final answer.